Hello students, this is Kiran Kumar, Faculty of Chemistry. Today in this session from the team of Chemistry Department, I will try to give the best revision plan for your coming exams. Before that, let me say a few words. Dear students, whenever we get more time, then there is a chance for more deviations. You may relax or you may deviate. But my advice to you, please try to be in the right path without any deviations for good success. Try to have a positive mindset and try to give the best from you. If you have negative mindset, there is no use. If you think, again the exam date is postponed, more number of days available again, and what about my exam? What to do? Like this, if you go in a negative mindset, there is no use. You are moving back in the race. Yes, competitive exam is one type of race. You must be in the right path in the race for good success. Dear students, don't allow your past to control the present. About your previous marks or your performance, whatever it is, leave it. With a positive mindset, let us move in this journey. If you feel like this, still I can get more time to solve more number of questions. I got an opportunity to correct my mistakes and I can do best in this time. If you think in this positive way, with this, you can do well. I hope you understood. Let us keep moving with much positive energy, dear students. Generally, at these times, whenever I get a chance to interact with the students, I would like to advise them to have a good revision plan. For a basic idea, I will give one plan. See students, in the coming days, first we have chemistry full test exam. After that, we have a first year grand test, then second year grand test, then full grand test, finally Neet exam. This is what the journey. So, for the coming chemistry full test exam, my advice is, try to spend 2.5 days, total you can get 6 number of days, right? 2.5 days you can spend for 11th class, and 2.5 days for 12th class, and 1 day to revise the important points. By the full test of chemistry, you can complete one level of preparation. If not possible to complete one level of preparation, then at least try to finish by the first year grand test or by second year grand test. By second year grand test time, you must finish one level of preparation. Then what happens? From the grand test, full grand test onwards, you can focus mainly on the question papers. Understood, students? My intention is one level of preparation of all the chapters you must complete by full test of chemistry. At least, if not possible, by the end of second year grand test, you must finish one level of preparation. Then, from full grand test onwards, our complete focus is on question papers. You can select cycle test papers, GP NAT papers, previous exam papers, or any other institute papers that are available with you. Try to solve n number of question papers. You know one thing, while you are solving the question papers at that time, suppose you are solving particular question paper, one question concept is not clear, then go back to that particular concept from the notes or textbook, refer that, get command in that particular subtopic, come back, continue the journey of question paper solving. After some number of questions, this particular question concept is not clear, then again open the notes or textbook, clear it, get complete idea about the concept, again come back, continue the journey of solving question paper. I hope you understood. You are supposed to solve n number of question papers with very good perfection in this manner. You know one thing, If you really solve around 20 question papers, after solving around 20 question papers, you will get very good confidence, very good command on different subtopics. So anyhow, like this, you plan your preparation for the coming exams. Once you do like this, then you will be very comfortable in the final NEET exam. Hope it is clear to you. During this journey, after completion of one level of preparation, you are supposed to segregate the topics. For the better revision purpose, you are supposed to segregate the subtopics. Why? See students, most of the students are facing one problem, a big problem. What is that? They express like this: sir, there are many number of reactions, many subtopics, many concepts. I am able to read, sir, but in exam time, during the exam time, I am not able to recollect those things. This is what they express. Why? Why means the problem is they are not able to segregate properly all the subtopics available. Dear students, suppose I have given a question to you. You can solve the question. I can also solve the question. That is not the matter. In exam hall, who can solve the question quickly with more accuracy, he is the winner in the exam. I mean, clarity in thought. In exam hall, clarity in thought is very, very important. If you have a very good clear picture of different subtopics in your system, in your memory, then you can easily recollect. Understood? For example, observe this for few seconds. Yes. After that, observe this one for few more seconds. Yes, come back. Tell me, what is the difference? When the files are like this in your system, I mean the different subtopics, if the different files in your memory are like this, which is not in ordered way, just like mess everything, right? If the different files in your memory are like this, you cannot recollect in exam very fastly. But if the files are segregated like this manner, see, nice segregation is there, different books. Such a way, if different topics are segregated very systematic way in your memory, then it is very easy to recollect in exam hall. For this purpose, I will try to guide you something. This is what the target of my lecture. This is the secret of the successful students. I mean, after one level of preparation, you must revise again and again different subtopics in this manner. After segregating the topics, you must revise. In a comfortable journey, you can recollect all the things in exam hall. In my last live video session about this, I have given a basic idea. But now, in this video, I will try to give a detailed explanation about this. And in this video, I will also try to give different approaches for the good revision. Please try to watch the full video. Let us start our discussion. Let us start with organic chemistry. Dear students, try to collect all these points on a paper. Whenever you start the revision of organic part or inorganic physical in coming discussions, you can use this type of segregation you can use for better revision. See, organic chemistry, these are the main tracks: IUPAC naming, isomerism, electronic effects, electrophile, nucleophile base, mechanisms. All mechanisms we should collect in one place. All the named reactions, I will list out all the named reactions, list I will give on board, whatever you need for our final exam point of view. I mean list I will give, priority order. and neighborhood reactions after, I will collect all reduction reagents. Just I will write reduction reagents. The collection I will give. Together we should prepare. Then oxidation reagents, all the oxidation reagents collection, followed by all the compounds, functional groups tests. And some important set of reactions, some interesting reactions we will find in organic chemistry, that set. I mean, I am not going to explain details of that. What is my target of this video? As I said, I am going to segregate, I'm going to group them so that the revision will be comfortable during the coming test preparation. And some important rules, Grignard reagent reactions, followed by purification of organic compounds, qualitative, quantitative analysis, and left topics, and any other thing, any other reactions. So this is what the correct way of dividing the organic chemistry topics. Now, if you take first one, IUPAC naming, hope it's very comfortable to you. You can expect a question in IUPAC naming in exam. Yes, a basic level question you can expect. So try to practice the rules first level. And isomerism, particularly the stereoisomerism is a very interesting part, apart from structural isomerism, where you need to focus mainly on tautomerism. Keep in mind, we can expect a question on tautomerism in case of structural isomerism. Apart from that, in stereoisomerism, they are mainly highlighting geometrical isomerism. So you are supposed to revise geometrical, optical, conformational isomers, all this, but you can mainly expect a question from geometrical isomerism part when you consider the stereoisomerism. And when we consider structural isomerism, mainly you can expect the question from tautomerism. And when we come to electronic effects, again separately I have given, this is what the table of electronic effects, you must revise all these in one stretch. I mean, inductive effect, resonance effect, hyperconjugation effect, electromeric effect. These are the main effects. Apart from that, also join with aromaticity concept. Aromaticity is also one of the important factor which can decide many things. So after revising all this, immediately start collection of all this. I mean, acidic nature orders, basic nature orders, stability orders. 100% there will be one or two questions in the exam paper based on these concepts, no doubt at all. That much weightage we have for these topics. You may not get direct question from this, but this will be the part of the question in the journey. I hope you understood. Acidic nature orders all should be at one place. All you must revise in one stretch. Wherever acidic nature orders are there, they must be in one stretch. I mean, acidic nature of alkynes, terminal alkynes, there you can start. After that, acidic nature of alcohols, phenols, substituted phenols, carboxylic acids, aromatic carboxylic acids, sulfonic acids, right? So all orders you can collect here. Basic nature orders about the amines, mainly aromatic amines, aliphatic amines, what about their basic nature? And stability orders of carbocations, carbanions, free radicals, how different electronic effects are going to decide the stability orders. Try to revise all of these in one stretch. Clear? Come back. Next, electrophile, nucleophile, base, basicity, nucleophilicity. Very interesting words. Electron deficient compound, electron rich compound, electrophile, nucleophile, reagents. Base and nucleophile, both are electron rich species only. But when the electron rich species is going to attack on H plus proton, then that electron rich species which attacks on proton is said to be base. The electron rich species which attacks on carbon having positive charge, partial positive or full positive, that is called as nucleophile. Most of the students are getting confusion here. Let me clarify once again. Nucleophile or base, both are electron rich only, but the electron rich person who is going to attack on proton is said to be base. The electron rich person who is going to attack on carbon is said to be nucleophile. And how fast it's going to reach the carbon is said to be nucleophilicity. How fast it is going to attack the proton is said to be basicity. Like that, have a very good idea about these terms which are going to come in different places of the mechanisms. Next, if you consider mechanisms in 11th and 12th parts of organic chemistry, whatever the mechanisms are there I am going to collect on particular place now. You try to note down. When we consider 11th and 12th chemistry, organic chemistry part, these important 10 mechanisms you need to revise again and again. I mean, together all these 10 mechanisms at a stretch we have to prepare. How? First, you need to prepare free radical substitution reactions in alkanes. I mean, for example, if you take methane chlorination, you will get methyl chloride. Ethane, which will give ethyl chloride. Propane case, you may get 1-chloropropane or 2-chloropropane. In that case, by knowing the mechanism, you need to prepare the mechanisms of all this. You can decide which will be the major product, which will be the minor product, what is the reason for that. Those things you can cover here. And electrophilic addition reactions in alkenes. I mean, if you refer the alkenes chapter, there addition of water in the presence of acid to alkene and HX addition, bromine addition, halogen addition. So like this, those type of reactions, they all belong to electrophilic addition reactions on alkene. Similarly, free radical addition reactions of alkene in presence of peroxide. How the free radical addition takes place on alkene. For example, HBr addition to propene, that you can refer for the mechanism. By having a good idea about these mechanisms, you can do well for different reactions, different applications in coming topics. And electrophilic substitution reactions in benzene. This particular topic will come again and again in many places of second year organic chemistry also. This you can find in first year organic chemistry. I mean, electrophilic substitution reactions in benzene, how to create electrophile, how the electrophile is going to attack on the benzene ring, right? And then here, what are the compounds which are more reactive towards this mechanism, which are less reactive towards this mechanism. And if you take a mono-substituted benzene, I mean, already on benzene particular group is there. In presence of that, when you do electrophilic substitution, so that electrophile will be directed to what place? Whether it is going to be directed to ortho place or meta place. What is the reason for that? Such things you can cover here, and you can mainly focus on mechanism followed by 5 important reactions here. I mean, halogenation, for example, chlorination. I mean, one type of halogenation, okay? Halogenation, sulfonation, nitration, Friedel-Crafts alkylation, Friedel-Crafts acylation. These 5 things you need to be very clear from this. And you know one thing? The same type of reactions you will get in different places in second year, like in chlorobenzene and in benzaldehyde, in anisole, benzoic acid, aniline. Like this, in different places we will find the application of this mechanism. Next, these are all the mechanisms that we will find in second year organic chemistry. In haloalkanes and in alcohols chapter and also in ethers chapter, we will find the importance of SN1, SN2, E1, E2 mechanisms. See, what is the way of preparation? First, I am going to focus on all the mechanisms. I will learn all these mechanisms. For example, how I will prepare SN1? Basic idea first of all. What are the important key points of SN1 mechanism? What is more reactive towards SN1? What is more reactive for SN2? And then, how to decide the correct product by SN1, SN2 mechanisms. Similarly for E1, E2 cases. After that, now once you open the different reactions, see, once you revise all the mechanisms, now you open the notes or textbook, you can easily refer all the reactions. You can easily recollect based on these mechanisms. Dear students, I hope my intention is clear to you. instead of reading during the revision time. See, already one level of preparation over. Now, during the revision time, again reading chapter wise. Instead of that, first I will prepare all the mechanisms and I will work out maximum on these mechanisms. Now I will open the textbook chapter wise, then whatever things remaining that you can refer very fastly. And then effectively you can memorize. That is what important. Come back. So in the case of alcohols, for example, alcohols with HX, PCl5, PCl3, SOCl2, how they are going to react, whether by SN1 or SN2, all these things you can cover there. And during elimination, during dehydration of alcohols or dehydrohalogenation of haloalkanes, what type of elimination you can find, whether E1 or E2, what are the conditions, which is reactive for E1, E2, what are the intermediates there, very important, all the key points, reactivity orders, and correct product based on the mechanism. This I will practice first. Similarly, in carbonyl compounds, you will find one important reaction, nucleophilic addition reaction. What is the correct reactivity order of the given compounds towards nucleophilic addition? Very famous question, that one. Followed by different reagents they will give. When I add HCN, when I add NaHCO3, and when we add, for example, in the presence of acid, when I add water, what happens? When the presence of acid, when I add alcohol, what happens? You will get hemiestol, histol formation, and the addition of NH2Z model. Derivatives of ammonia. Those reagents, when we add to carbonyl, what happens? What type of mechanism there? Mostly they will follow nucleophilic addition type mechanism. Followed by nucleophilic acyl substitution in acid derivatives. You know that acid derivatives means, for example, this is what RCOOH is carboxylic acid. In this place, if I write a group like L place, let us imagine halogen, acid halide. Imagine OR, ester, NH2, amide. So like this, acid halides, anhydrides, amides, esters, they are going to involve in nucleophilic acyl substitution mechanism. What is the correct reactivity order? You know, all these mechanisms are given in NCERT at different places. All are very important from NCERT, all these. You have to prepare like this. First set of mechanisms, 10 mechanisms. Fine, I got very good perfection, good command on the mechanisms. Then I will move to few more. Try to revise these mechanisms also. Nucleophilic substitution reactions in haloarenes. You know one thing, these are also given in NCERT. How means? They have given chlorobenzene, for example. Very popular question. Chlorobenzene towards nucleophilic substitution, not reactive. That's why very high temperature, high pressure condition, we can get phenol from chlorobenzene by nucleophilic substitution reaction. To make it simple, we need some conditions. What are the conditions you need? Like that they will create the questions. For example, if you have a NO2 group on haloarene, then this reactivity will be more. So suppose if you have more number of NO2 groups on chlorobenzene, then this substitution is very easy for that haloarene. Similarly, allylic halogenation concept. Popular questions are there from this. When we give NBS, N-bromosuccinamide, that is one allylic halogenation reaction reagent, and halogen under a high temperature condition that can also cause for allylic halogenation by free radical substitution mechanisms. So allylic halogenation mechanisms and their reactions. So these are also very important. And up to this you can prepare, students, no doubt, all these reactions including mechanisms. If time is there, just have an idea about SNI and even CB mechanism. These are not very important. At end you prepare depending on the time factor. I hope you are clear regarding mechanisms. Student have to get very good command on all these mechanisms and this. At end time is there this. So after this you can enter into different reactions given in textbooks. You can easily memorize. You can easily answer the questions if application is given on that. When you consider the next part, Nemood reactions, from 11th and 12th organic part, you can find the following named reactions. Around 30 named reactions list I am going to give. That is very, very important set. You must prepare. Like Wurtz reaction, fatigue reaction, Wurtz fatigue reaction, Kolb's electrolysis. I am going to give dot for that. Wherever I mention the dot, those cases you need to prepare the mechanism also. See students, every reaction has mechanism, no doubt. But you need not to prepare mechanism of all. For your syllabus point of view, you can answer the questions. Some cases without mechanism also you can do it. So I would like to highlight where mechanism is very important. Kolb's electrolysis case, mechanism based questions we can expect. Even Friedel-Crafts alkylation case also you can expect some questions about the different rearrangements of the electrophile. And Friedel-Crafts acylation, Sandmeier's reaction, Gattermann reaction, Hans-Dicker reaction, Finkelstein reaction, Schwartz reaction, Williamson synthesis reaction. It's a very interesting one. And Kolb's reaction, Riemann-Tiemann reaction, Rosenmund reduction, Stephens reduction. You know all these reactions. You can easily recollect all this. Whenever a named reaction is given, you need to focus on what is the reactant, what is the reagent we are adding, what is the product. Like this you have to prepare. I mean, for example, if you take Wurtz reaction, alkyl halide sodium gives alkane. So like that, main reactant, reagent, product you have to memorize. Such a way you have to practice. Come back. Next, Itard's reaction, Gattermann-Koch reaction, Clemmensen reduction, Wolff-Kishner reduction, and the cases where Clemmensen is preferable, where Wolff-Kishner is preferable, Aldol reaction, Cannizzaro reaction. Maximum chances to get a question from Aldol and Cannizzaro. You know the importance of these two. Then HVZ reaction, Gabriel thalidomide synthesis, which we use to prepare primary aliphatic amines, not aromatic amines. Why? And then Hoffmann-Bromamide degradation reaction mechanism, including the intermediates, carbalamine reaction, diazotization reaction, and very interesting one, Kleisel-Smith. Kleisel-Smith is also one type of aldol model, and bivalent blank reduction, Sabatier-Sanders reaction, nothing. Very simple reaction this one. Addition of hydrogen to unsaturated compounds in presence of metal catalyst like nickel. Come back. Scott-Baumann reaction. Like this you will find around 30 reactions list I have given. Dear students, don't neglect any of this reaction. Your first task is prepare all these reactions at a stretch. Together you prepare all. Some places, please practice the mechanism also. Some places, just read the reaction. See, one level you have to prepare like this. Once you got very good command on these 30 reactions, around 30 reactions are there, then named reactions are under your control. In NEET exam, you can perform well regarding the named reactions. After this preparation, first task this one. If time is there, go for second set. Time is not there, first stick to these and go for next topics. If you are already clear about all this, perfection is there. If you have time, then my advice, try to have an idea about these reactions in this order also, again in this order, depending on your time. These are not very important reactions for our syllabus point of view. In our syllabus point of view, these must, I mentioned already, you must prepare all these. Very good command you need. Come back. If you have time, just have an idea about this, otherwise you can leave it. What are these? Perkin reaction, pinacol-pinacolone rearrangement, benzoin condensation, Bayard-Villiger oxidation, Beckmann rearrangement, benzoic acid rearrangement, Birch reduction, Kleisen condensation, Diels-Alder reaction, Naviengal reaction, Reformsky reaction, Oppenauer oxidation, Mervin-Pondorf Valley reduction. Like this, you can observe this. So this is what the correct division of named reactions and the right way of preparation. Please focus on first set mainly. When you consider reduction reagents and oxidation reagents, for these you try to revise all these together like this. I mean, under reduction reagents, you need to cover all this during revision session. Palladium or nickel, platinum, any of the metal in presence of that hydrogenation. Palladium and carbon presence reduction. Sodium borohydrate, lithium aluminum hydrate. What is the difference? What are the functional groups that it can reduce, like the difference of these, such a way you need to observe. Dibolage, very interesting part you can find in carbonyl chemistry, and sodium liquid ammonia, its reactions, tin and HCl presence, and sodium ethanol reaction as a reducing reagent, red phosphorus HI, one of the strong reducing reagent. So about this, you need to have a basic idea about reducing reagents, which are given in NCERT. So we need to read all this together. Similarly, when you consider oxidation reagents, collect all the oxidation reagents on paper like this and try to have a basic idea about these reactions. I mean, copper at 573 Kelvin, when we add primary alcohol, what happens? Secondary alcohol, what happens? Like that you prepare. Similarly, acidified KMnO4, alkaline KMnO4 reactions as their oxidizing reagents, very good oxidizing reagents, and acidified dichromate case, Jones reagent reactions, PCC, PDC, how they are going to oxidize the alcohols to carbonyl, and HiO4, how it is going to cleavage, its cleavage of CC bonds, where we have diols, adjacent diols, 1,2 diols, or we have a alpha hydroxy carbonyl. In that cases, how it is going to cause for CC cleavage, those reactions you can focus. Similarly, osmium tetroxide, how it is going to convert the given alkene to glycol, 1,2 diols you can get by OSO4 from alkene. So these are very basic reagents. In NCERT, these are very much highlighted. You need to cover all these important reagents, these 9 reagents. If time is there, just observe it. Otherwise, leave about SeO2, MnO2, just have an idea. I hope I am able to give the important list of reduction reagents and important list of oxidation reagents where we need to focus during revision time. The next topic, if you consider tests of different functional groups and followed by some important set of reactions. Together, how we can prepare during revision time. You see here, while you are preparing the organic chemistry, at different places you will find tests like this: alkene test, alkynes test, even terminal alkyne test, right? And alcohols test, followed by phenols test, carbonyl compounds test, how to identify carbonyl group by 2,4-DNP, Brody's reagent. And also here you can find how to distinguish aldehydes and ketones by Tollens, Feilings, Benedict, Schiff's, like these reagents we can use. And carboxylic acids, very interesting reaction you will find about sodium bicarbonate reaction, right? They are going to evolve CO2 gas. Amines, how to distinguish aromatic amine, aliphatic amine, and in case of primary amine, secondary amine, tertiary amine, how to distinguish them by using Hinsberg reagent, by using HNO2, nitrous acid, right? Carbalamine test. All these you can refer here, followed by diazonium salts test. How to identify the presence of diazonium salt by coupling reaction we can find. So all these tests together you can prepare so that it is easy to recollect. Followed by, there are some tasty reactions, important set of reactions. Very interesting reactions have much weightage in exam. You know, for example, esterification reaction. In case of esterification reaction mechanism, if you refer, there different previous model exam questions you will find. I mean, what are the more reactive compounds towards esterification reaction? Similarly, which of the following are more reactive towards ester hydrolysis? Like that, based on the mechanism, you can find the questions. And what is the correct cleavage? Where we are going to get CO cleavage or OH cleavage, correct cleavage to get the correct product. That is what the interesting part here. So prepare these esterification and ester hydrolysis reactions followed by ether, unsymmetrical ether with hydrogen iodide. You know the importance of this. So where cutting takes place, or this side cutting, O carbon, or this side cutting. What type of cleavages take place to get the correct product for the ether with HI. And ozonolysis reaction, very famous reaction, many places you will find, followed by iodoform test, CH3C double bond O or CH3CHOH. The groups like this, CH3CO in carbonyl, CH3CHOH in alcohols, those groups can be identified by adding base and I2, which give iodoform, yellow color compound. So this reaction has much importance in different places. And decarboxylation, by soda lime, how to do decarboxylation, or in the case of beta keto acids, by heating, or in the case of gem dicarboxylic acid, by heating, how decarboxylation takes place. And very interesting part, cyanide to acid and acid to cyanide. By hydrolysis in the presence of acid, you can convert cyanide to carboxylic acid. Similarly, carboxylic acid to cyanide, by adding ammonia and heating in presence of P2O5, you can convert acid to cyanide like this. Interconversions, you see, very important reaction in organic chemistry. Similarly, benzene diazonium chloride reactions and diazotization reaction, benzene diazonium chloride preparation, this one. You can also find applications related to mechanism of coupling reactions of benzene diazonium chloride. Benzene diazonium chloride can cause for coupling reactions. In those cases, what is the reactivity order when we give different compounds like phenol, aniline or substituted aniline, those cases with respect to BDC, benzene diazonium chloride, related to coupling reaction, reactivity orders. So these are all some special type of reactions which play a very important role, and all are given in NCERT. You need to prepare as a set. Understood, students? So try to collect all these tests one place, and at least that you read and try to collect all these interesting, important reactions in organic chemistry and revise like this. Hope it is clear about this. Now, if you observe next point, important rules. After this, let me take important rules. In this case, you can refer 4 important rules. Let me read. Markovnikov rule, anti-Markovnikov rule, Sedgeff rule, anti-Sedgeff rule. Come again. These are the 4 important rules which play very vital role in different places of the reactions. I hope you know the importance. Important rules like Marconi and anti-Marconi rules during addition. Sedgeff, anti-Sedgeff rules during elimination. So please observe those. And what are the conditions where Marconi, anti-Marconi, where Sedgeff and anti-Sedgeff products, anti-Sedgeff other name Huffman elimination, Huffman product, anti-Sedgeff or Huffman product, Huffman elimination, meaning same. So what are the conditions of those particular rules? I mean, where Markovnikov rule is important, where anti-Markovnikov rule we have to apply. Similarly, where we have to apply Sedgeff rule. The same time, anti-Sedgeff, other name Huffman product, where we can apply this. What are the conditions for Huffman? For example, when we have a bulk base, when we have a poor leaving group, or when we have quaternary ammonium salts, and during the pyrolysis of esters case. So like these cases, we will find Huffman products. So where is Sedgeff product possible? Understood? Sedgeff, anti-Sedgeff. Anti-Sedgeff other name Huffman product. Overall Sedgeff and Huffman during elimination. Marconi, anti-Marconi during addition. Together you read all these in one place. Easy to recollect then. Next one. Coming to Grignard reagent. Wherever you find Grignard reagent reactions, group in one place. For example, I will tell you where can you find Grignard reagent reactions. in first year, alkane preparation, alcohol or acids or one terminal alkynes, primary amines, water, etc. with Grignard reagent, they can give alkane. Similarly, in second year, Grignard reagent preparation you will find from alkyl halide plus magnesium metal, you will find RMGX. And similarly, in second year, under the preparation of alcohols and carboxylic acids, under properties of carbonyl compounds, you will find the use of Grignard reagent. Grignard reagent with formaldehyde, with other aldehydes, with ketones, with acid halides, anhydrides, cyanides, and esters, and Grignard reagent with carbon dioxide, it's going to give carboxylic acid. Grignard reagent, carbon dioxide will give carboxylic acid. Similarly, we can find the Grignard reagent reactions in different places. You can feel it right now. You can collect in one place. At a stretch, try to read the Grignard reagent reactions. Similarly, please observe purification of organic compounds and qualitative, quantitative aspects. What are the atoms present in the organic compound? Conformation test of nitrogen, carbon, sulfur, phosphorus, halogens. Similarly, how to estimate the percentage of carbon, hydrogen, nitrogen, sulfur, chlorine, phosphorus. Here, some interesting methods like Gildahl method, Dumas method, very useful to find out percentage of nitrogen. Popular questions are there in previous exams based on that. Gildahl method and Dumas method mainly. And finally, any left topics or reactions, that set you can collect here. So if I leave anything, just try to, I'm giving the basic idea to you. Hope I am able to collect maximum things here, but if anything is missing from NCERT mainly, try to write as a left topic list. So my intention is, regarding organic chemistry, I have a segregation of different topics like this, and during my revision time, whenever I go for revision for a grand test or a final test, whenever I am going for revision of particular part of chemistry, organic chemistry revision, I will segregate like this. This flow chart I will keep with me and I will always open it. I will read these words. Once if I read these words, the flash should come about all this. Suppose here basic idea I have given. Suppose mechanisms. Immediately I should open mechanisms chart. I have given, right? That chart. Once you read that line, total key points, intermediates, all the things should run your system. A flash should come. Such a way you have to prepare. Like that you are able to recollect fastly means you are perfect. You are not able to recollect. Don't worry. Again you prepare those sets of reactions. So like that come back. Go for next test. So please try to understand. My intention is try to segregate like this and prepare well for organic chemistry.